Hi everyone. So in today's video lecture, we're going to talk about synchronous versus asynchronous programming. Let me start with synchronous programming first. Um, so in synchronous programming, and synchronous programming is also known as blocking or sequential programming. In this type of programming, the execution of code occurs in a linear manner. When function is called, it blocks the execution of the program until it completes its task and returns a result. During this blocking period, the program cannot continue executing other tasks. So if we have three programs, P1, P2, and P3, in synchronous programming, first P1 will execute and finish its execution, then only P2 can start its execution, and so on. If we talk about asynchronous programming. So this was synchronous. Now let me give you a brief idea about asynchronous because we already discussed asynchronous in previous video lecture. So you can go check that video as well. So in asynchronous programming, which is enabled by, as you know, async and await in Python, and we already discussed that in the previous video lecture. Asynchronous programming allows the program to execute multiple tasks concurrently without waiting for each task to complete before moving on to the next one. It achieves this by utilizing coroutines and an event loop, and we discussed all of that in the last video lecture. So please go check that video. Now let me talk about a few differences between synchronous and asynchronous programming. So the very first difference is blocking versus non-blocking. Synchronous code blocks, uh, in synchronous code blocks, the execution is until a task is complete, while asynchronous code allows other tasks to continue execution while waiting for input output or other operations to complete. So in synchronous, one task has to finish before the second one can start. In asynchronous, it's not the same. It does not wait for a task to finish to start the other task. Another difference is concurrency. Synchronous programming typically handles concurrency by creating separate threads or processes. So there is a concept of threading, and um, there are multiple processes used. And in asynchronous programming, on the other hand, concurrency is handled within a single thread by allowing tasks to be scheduled and executed concurrently using an event loop, right? So concurrency is achieved in synchronous programming using separate threads and in asynchronous programming using event loops and coroutines, of course. Another difference is responsiveness. So asynchronous programming can improve the responsiveness of an application, especially when dealing with input-output bound operations. By not blocking the main thread, it allows the program to respond to other events or user interactions while waiting for input-output operations to complete. So responsiveness is more in asynchronous programming than in synchronous programming. Another difference is efficiency. Asynchronous programming can be more efficient in certain scenarios, particularly when there are multiple input output bound tasks. By executing tasks concurrently and efficiently, scheduling input output operations, it can lead to improved performance and resource utilization. So, efficiency would be more in asynchronous programming, but it also depends on the situation, right? Um, so, it's worth noting that while asynchronous programming can bring significant benefits in certain situations, it may introduce additional complexity and is not always the best approach for all types of tasks. So, careful consideration should be given to the specific requirements and characteristics of the application before deciding whether to use synchronous or asynchronous programming techniques. Now, let me give you one example, and just to help you understand the concept of synchronous and asynchronous programming while executing programs. I'm going to create a very simple program. Um, I'm not sure if I'm going to run it because I'm actually running short of time here. So let me give you one example of synchronous programming first. So I'm going to create a function, and let me create it first, and then I will explain. So with open file underscore path, and we are trying to read this file as file, and we're going to fetch some data, file dot read, and then we're going to print, and so I'm going to use I'm sorry, read. So here I'll have file path, and here I can have data, right? Okay, then I guess I can have another function main, and in this function I'm going to create many file paths using a list. So suppose file1.txt, and then I can have maybe file2.txt. And if you're not familiar with these terms, I would link that one video lecture on files in Python. You can go check that as well. So for path in file underscore paths, read underscore file path main. All right, so let me explain this code. In this synchronous programming example, so this is a synchronous programming example, we have a read underscore file function. And this function opens and reads a file. Okay. The main function iterates over a list of file paths because this is the definition of main here, right? So this function is going to iterate over a list of file paths, and it calls read underscore file, right, for each path. Okay. And the program waits for each file to be read completely before moving on to the next file. Okay. Okay. Let me break it down. So the read underscore file function takes a file underscore path parameter. So I'm going to explain you every statement. I'm going to illustrate this entire example just so that you can understand it in a better way. So the read underscore file function takes a file underscore path parameter, which represents the path to a file. Now inside the function, it opens a specified file using the open function, right? So this is an open function, and assigns the resulting file object to the file variable. Okay, so this is our file variable, and the file is opened in read mode, right? So this is read mode R, and the with statement is used to ensure that the file is properly closed after it has been read. Okay, this helps with managing system resources and avoids potential issues with file blocks. Within the with block, so inside this block, the file.read method is called to read the contents of the file and assign it to the data variable. Finally, a message is printed that indicates the file path and the data that was read from the file. Right? Moving on to the main function serves as the entry point of the program. So it defines a list called file underscore paths that contains three file names: file1.txt, file2.txt, and file3.txt. a loop is used. So this is for loop, right? So a loop has been used here to iterate over each file path in the file underscore paths list. For each iteration, the read underscore file function is called with the current file path as an argument. This results in the corresponding file being opened. Now, right now, I don't really have these files. So when you try to run this code, you must have these files, right? So these files, make sure these files have already been created. And like I said, this results in the corresponding file being opened, read, and its contents printed. The main function is then invoked at, at the end of the script, causing the program to execute the code within it. And in a nutshell, in summary, this code reads the contents of three files, file 1, 2, and 3, using the read underscore file function. Each file is opened, its contents are read, and the file path along with the data are printed. Now, let me give you another example with asynchronous programming. So, if I want to have asynchronous programming, if I want to work with that, what I need to do is, first of all, I need to import async IO, right? And then def read underscore file path with open file underscore path as file. Yeah, this would work. Data file dot read file data. I think this will work. I only need to add async keyword here. And similarly, def main file paths 1, 2, 3 for path in. Okay, so async keyword here also, and I'll have to make a few changes here. So file underscore paths, that's fine. Um, yeah, because yeah, so for this one, I'll have to make a few changes. So let me start from here. So we have to create tasks, a list of tasks. So it will be read underscore file path for path in file underscore paths await asyncio dot gather. So we are unpacking the tasks here, and asyncio dot run main, right? Now, in this asynchronous example, we define an async function called read underscore file that reads a file. The main function creates it creates a list of tasks by calling read underscore file for each file path. We use asyncio.gather to schedule and execute these tasks concurrently. To run the asynchronous code, we use asyncio.run, okay, to create an event loop. Execute the main coroutine and wait for it to complete. When comparing these two examples, the synchronous version reads one file at a time, blocking the execution until the current file operation is complete. On the other hand, the asynchronous version starts reading multiple files concurrently, allowing the program to move on to other tasks while waiting for input output operations to complete. Asynchronous programming enables better utilization of resources and responsiveness, particularly when dealing with input output bound tasks. And multiple files can be read simultaneously, potentially improving overall performance. Okay, so it's important to note that for input output bound tasks, the benefits of asynchronous programming are more prominent. In CPU bound tasks, where computations dominate, the gains might be less significant, and synchronous programming can still be sufficient or even preferable. So this was the main difference between synchronous and asynchronous programming. If you decide to run these codes, make sure that these files are already created. Okay, I hope the difference was clear. If you have any doubt, you can always ask in the comment section below this video. I will see you in the next video lecture. Till then, take care.